In this video, we're going to talk about proof by induction in discrete mathematics. And then we will have a summation formula that we're going to prove with induction. So whenever you want to prove anything in induction, you have to follow two steps. First step is called basis step. In basis step, you have to prove that the first element follows your formula. So in this case, we are going to call it P1. So verify P1 is true. So you first prove that the first element, your formula worked for the first element. That's the first step. The second step is called inductive step. In this step, we first assume that P of K is true. If P of K is true, then based on this, we want to prove that P of K plus 1 is true. So remember these two steps while we are going through our example. So our summation formula is 1 plus 2 plus 3 plus ... That means it will keep going until it reaches a number called n. And then the formula for this is n plus 1 divided by 2. So that means any number of integers that you're adding together, you can get this formula, you can plug it into this formula, and after that, when you get the answer, you will get the summation of all the numbers to the n. We have 1, 2, 3, 4, 5, 6, 7 until we get to n. This part of our equation is equal to this part of our equation. So that means that any number till n, when you add together and then you plug it into this formula, you will get the summation of those numbers. Element of this equation follows the rules of this formula. So that means we have to plug it into this formula and make sure the other side of the equation is 1 as well. So 1 is equal to, our n is going to be 1 because we only have 1, and then the other n is going to be 1 because still we have 1, and plus 1 divided by 2. So 1 plus 1 is 2, 2 and 2 cancel out. So from here we understand that 1 is equal to 1. So the first step is correct. So our formula works for our first step. Now let's look at the second step. For the second step, for our induction step, I'm going to rewrite the formula. I'm going to rewrite the equations plus, but this time instead of n, I'm going to put k because we were talking about P of K. And as you remember, in the inductive step, if pk is true, then we want to prove that pk plus 1 is true as well. So here, if you want to rewrite the formula with k, I'm going to just write down k plus 1 divided by 2. So this is basically n plus 1 divided by 2, and instead of k, it's going to be n. Okay, so this is something that is already, we're assuming that it is true. We're assuming that this holds. What we want to prove is that 1 plus 2 plus 3 plus ... plus k plus k plus 1. So that means it doesn't matter what our k is. If k is 1000, k plus 1 is going to be 1001. So in this case, because we have the two last digits, let me show it to you here. So we have k, which is the last digit, and then we have k plus 1 here. All of these divided by 2. Now if I want to rewrite this equation, this is going to be different because my last number here is k plus 1. It's not k anymore. So what I should write here is k plus 1 instead of k, and then multiply by k plus 2 divided by 2. So I want to prove that this is equal to this. I want to say that this formula works. I want to prove that this formula works for whatever number that you're adding together. So this way, I'm going to use k plus 1, k plus 2 divided by 2. Now, how are we going to prove this? We have 1 plus 2 plus 3 plus dot 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 plus k plus 1. So till here we understand what's happening because we want to prove k plus 1. And then on the other side, I first write my own equation, which is k multiplied by k plus 1 divided by 2. And after that, I have another k plus 1 here, which I'm going to add at the very end, k plus 1 at the very end. So I'm not going to write this part of the equation anymore. I'm just going to say this is equal to, this part of the equation is equal to, if I want to have the same, if I want to have denominator 2 for both of those, okay, this is not good. So then I have k plus 1, and then for the next part I have 2 because there is the denominator 2 for this part of my equal. So I'm going to put k plus 1 like this. And then if you notice, we have k plus 1 here and we have k plus 1 here. So what we can do, we can factor that out. So what we are going to get is k plus 2, k plus 1 divided by 2. So this part of it was mostly algebra. So as you can see, k plus 2 multiplied by k plus 1 divided by 2, that means here is equal to this. So right now, we just proved that this formula works by first showing that first step works, which is the basis step, and then the second step, which is inductive step. I hope this video was useful for you, and see you in next video. Bye.